Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about digital transformation strategy and architecture. When I talk to organizations about how to effectively transform their organizations to be more digital, we always look at three key elements. We look at organizational, procedural, and technology, or people, process, and technology, for no better word. And we see how we can coordinate all three of those movements of change together so that we have an organization that's balanced or a solution that's balanced as we move forward. It's important to understand, first off, where you're currently at with each one of those and where you want to get to. Without a map on where you want to get to, your organization tends to just go with the latest and greatest technologies that are out there, or the latest process, or I heard about this new organizational change, and you get lost. You really get lost quickly, and then your digital transformation kind of falls flat. So having a plan is extremely important, but knowing where you want to end up is probably the most important part of that. So let's take a look first at organizational change. When we look at organizations, we tend to group them into divisions or into groups. And every group I've talked to has these main groups that we see, and some of them are new groups that we haven't seen before, that are new. But let's talk about the ones that we understand first. The first one is your dev team. And whether this is software, services, or hardware, it's your development team. They're developing new product offerings, whatever they may be. Almost every development team today has some kind of agile, or they like this quick iteration movement that has really taken hold in most organizations, most industries today. All of your dev teams will focus on doing development work, testing it, and then pushing it out into production. This is very common. These processes are very well known nowadays and very mature. The next organization I want to look at is my IT organization. What motivates them? Well, the primary things that motivate IT organization are optimizing their infrastructure for cost and efficiency, making sure I have reliability, and making sure that I have control and security built in. These are the key things that motivate them, and they primarily look at compute, storage, network, compliance fits in there, cost fits in there. All these elements fit together that they need to worry about. Now, the next group that we want to talk about is your security team. Security teams have become extremely important as of late. Really taking off in the last 5 or 6 years, in the last year and a half, especially since COVID hit the last year. We're seeing security teams really kind of clamp down and try and figure out how to now manage an organization that's spread all over the place, people working at home. It becomes a problem. So they primarily focus on securing your intellectual property, your data, and your infrastructure. Common things that they use are identity management, protection, detection, remediation. These are the tools that they use in their world. So understanding high level, how they work, is important to your organizational change. And then the last group, and probably the newest group, even though they've been around for some time, you may have a pocket of a statistician or a mathematician somewhere in your org that does some data mining or some data science. Really, the data groups are really starting to take hold now with the advent of the chief data officer and organizations built out around them. Remember, their key focus is analyzing, categorizing, and delivering real value out of the data that's being produced in your organization. Whether it's a manufacturing organization or a services organization, whether you're trying to capture new customers or save money in your IT organization, there are so many different areas where data scientists can come to play. And remember, they're dealing with data, and also they're interacting with a lot of storage. So understanding the key elements of each of these groups is extremely important. Finding out where you're currently at, and then also where you want to get to. And remember, in order to make an effective digital change, we've got to get all of these groups actually working together so that they have a mutual understanding of each other and what each other brings to the table. That you have one vision, that your data scientists aren't off exploring some data that has no value whatsoever to your development team or your IT team. Or maybe your security team is locking everything down so tight that your development team can't get any work done and your data scientists can't get to the data that they need. So making sure that we have this common strategy, common process, common architecture ends up being extremely important in this as well. And when we do this, we can really get a good data transformation, that digital transformation that we really want to get to, where we're working as a whole team now with common goals and common outcomes would be ideal. Now, one of the areas that we've found, whereas the hardest area in organizational change is at boundaries. So when you've got a security team that needs to work with your IT team, we typically, at those boundaries, there's typically communication breakdown. And what we've seen is something really interesting. We have seen organizations create new roles and new things, new small groups that handle the coordination between these groups. For example, between security and IT, we have SecOps or SecDevOps, we've even seen the term, where they're automating in IT the policies and procedures that we're getting out of the security team. We're also seeing the same thing with DevSecOps, right? Where I've got development and I'm injecting security into my development teams. DevOps fits in this same boat, which is the intersection between development and IT ops. Some new ones that we start seeing coming up, and I've only seen a couple organizations really do well with this, is like data ops. I have a team that is just focused on delivering data to my data scientists team. A lot of times the data scientists want to work in their own little sandbox, but it's not reproducible because they haven't involved an IT organization that knows how to scale. They know how to have reliability, all of those things that your IT team focuses on. And then the last kind of new group that we're seeing form is your data dev team. And these guys are developers that are working with your data scientists to provide more repeatable processes through application development or integration of tools and applications together. So look for those four areas when you're combining your teams together and trying to come up with this one vision, one goal. Guaranteed that that role is being done by somebody, and sometimes helping someone by giving them a title or some training in that area will help smooth out any rough edges that you have when you're going through this transformation. Now, the last bullet I have on here, if you see, is common architecture. It is so much easier to go through these changes when you start looking at some common architectures and common tool sets that you can all rely on, that you can build your organization and your processes with that common architecture. So let's take a look at what this common architecture might look like. And this is kind of the utopian, the perfect system that doesn't exist today, but we really want it to. But we can look at all the elements and maybe build it by integrating tools ourselves. So we want something that's very self-service. So anytime that a data scientist needs more storage for data, they don't have to call IT and fill out a bunch of forms and get an architecture diagram with physical layouts in the data center. That just takes too long. So we want this like self-service portal where a data scientist can say, hey, I need 3 terabytes of storage for the work that I'm doing right now. They can go onto a self-service portal and get it. Wouldn't that be great? Now, your security team is going to say, hey, wait, I want to make sure the data scientist is watching out for our IP. So I want to make sure that it's policy driven so that when the data scientist drops confidential data onto a drive, onto storage, that it's encrypted, right? And that access control is automatically handled with it. So it needs to be policy driven. This will help your IT teams and your security teams with their compliance that they have to deal with manageability and all the things that you have there. Another thing I would really love in this system is that it is self-healing and data-driven, where if I do have an outage or maybe I have machines that are infected, that they're self-healing, where they're quarantined and workloads are migrated to other areas in my data center or off into the public cloud. I want this to be kind of a self-managing system that needs IT to establish policies and to watch things, but day to day, I want things to happen automatically. Wouldn't that be great, right? I also want it to be intelligent. I don't want it to be just following old rules. I want the system to learn from experience that it's done in the past. That would be ideal. I want to drive efficiency out. If you can see with this, it's a utopian system that doesn't exist today that I would really love to have. But let's take baby steps and let's look at what each organization would want in this architecture, because I think we can get a lot of this stuff today with common off-the-shelf products that exist today and integrating them together and getting everyone to use them, which I think would be great. So let's first take a look at IT, because to me, IT is responsible for the underlying infrastructure and data information that we have in the company. So if we could establish a rock-solid foundation that we could build on, then everyone else would build their stuff on top of. I think that I truly believe that that would be the case. So if I look at IT needs to move to like a multi-hybrid cloud solution so that I can easily orchestrate infrastructure as it's needed, whether it's on-prem in my own private clouds or whether I'm taking advantage of a public cloud or a couple public clouds. I want that flexibility where based off of policies that I have, maybe it's costs is my biggest concern, maybe it's reliability, and everyone says, oh, it's everything. Well, you can pay more for higher reliability or you can pay less. There's always trade-offs that you have to deal with. But the key here is that these two elements are important here. I have a software-defined infrastructure that lets me easily orchestrate compute, storage, network, security, and now even new things like memory and accelerators are now moving into that software-defined infrastructure layer. So this is a key aspect that you want in your common architecture, that multi-hybrid cloud foundation. Next, let's talk about security guys. The security guys have a whole lot of things that they would love to put into a system like this and make it as automated as possible. The first is what we call identity aspect. Now, this means that I can identify not only users in my infrastructure, but I can identify infrastructure, applications, services, so that everything has an identity and that I can tie those identities to specific authorization and access, make sure that everything's authenticated, and I'm going to have to manage keys across this infrastructure that could be in the cloud or on-prem. It could be all over the place. So having a good identity management system, important aspect here. The other one is my security side. So on the security side, there's key things I want to have there, like encryption. I want to be able to encrypt all my stuff. I want remediation when there are problems. I need to detect when there are intrusions or problems. And ideally, I would really love to establish a root of trust so that I can trust everything that's running in my ecosystem, both applications and services, as well, all the way down to firmware and BIOS in the machines in my ecosystem. Wouldn't that be great? Where I know nothing has been tampered with that's running in my ecosystem. Everything's been attested, so I don't have rogue things going on in my ecosystem. Now, I would love to do that. Security teams would say, yes, that's exactly what I want. Zero trust of everything, right? Establish a root of trust so everything can be locked down. But we got to talk to the developers, because the developers are like, hey, wait, if you're going to put all this process on top of me to get anything done, you're going to slow down my development. So I've got to come up with a way so that that can happen kind of automatically. Well, we're starting to see some real movements in this space. Most developers now are really focusing on reusable components that can be attested, that I can say, hey, this is guaranteed to not have malware in it. It's been tested. It was written by us. We know every line of code in there. And they're doing this through ecosystems like containers, right? Whether it's Kubernetes or Docker or Mesos, that ecosystem is growing and getting pretty strong nowadays. And the ability to inject security into that layer is very key to making it successful and moving into production. On top of that service layer, we have an application layer, which really, this is where developers can take advantage of workflows, whether it's developer services like your continuous integration and deployment and test systems, or maybe I'm tying applications together with like robotic process automation, where I'm doing workflow management now of underlying applications that are running in my ecosystem. So having both the service layer and the application layer on top of that are key elements that you want to have in this utopian architecture that you're looking for. Okay, I've got developers, I've got security, I've got IT guys watched out for. What about those data guys? Do we just push them off onto the side? Well, that's kind of what we've done in the past, right? We'll just give them some data and they'll be quiet for a while. Well, now that my data is now scattered across several different ecosystems, public clouds and private clouds, and even out on the edge, my data is kind of all over the place. So we really need something that helps your data scientists and also your application developers figure out a better way of managing data. Now, abstracting the data away from the storage is one of the key aspects here, so that I can now orchestrate data across this vast infrastructure that I have and not really worry about where the data is actually residing in the moment, but only tying that data to applications and or services that I need to do data analytics or AI ML type work, or maybe it's just an application needs it to get its work done. I want to abstract that so that the data in the application can land on the infrastructure at the best place at that period in time. And this could be out on the edge, it could be in a data center, or my application could be split into 1,000 parts, 1,000 replicas of itself, and processed in several different places. We need a layer that can help us manage the complexity of where our data is and how to access our data, including in there the security aspect that we talked about before, right? It's great if you lock down your infrastructure, but if you don't lock down your data, if you don't manage your data and access to your data, then the reason you have the infrastructure in the first place doesn't exist. We have the infrastructure so that we can manage data. Think about that. Every application that we have deals with data. Right? So how to manage that data is something that we're starting to see some startup companies in this space starting to move up into this space and kind of take control of the data management plane, this data information management layer. So this ideal architecture that we're coming up with, this utopian architecture of which there's a lot more moving parts, but this is kind of the high level that we're looking at. We actually call the Edgemere consolidated architecture. And we're trying to see how all these pieces fit together so that I can help organizations move into this digital transformation. The key here is understanding what each organization needs, what their use cases are, and doing the best to find commonality between the groups and to come up with a common framework or architecture that the whole group, your whole organization, can work in. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.